Hey everybody, it's Mr. Troy here. I hope everything is going to well. Well, we're off to a great start. Hey everybody, hope everything's going well. Lovely to see you, or not see you as the case may be. Hey everybody, hope it's going well. Hey everybody, lovely to see you. I hope it's going well. Welcome to e-learning. I want to acknowledge that things are going to be weird, but things have been weird, and we're just going to do our best. So hopefully you're going to be there trying to learn every day, and I'll be here trying to teach you every day. I've been fine. Thank you for asking. I appreciate it. As we embark on e-learning, I think our two biggest challenges are going to be staying organized, because you've got 6 or 7 different classes to do, and staying motivated. It's going to be hard a lot of times to wake up and just start doing work even though you haven't left your house. Just do your best. Make sure you're trying to do work every day. The normalcy will help. Everything in this class is going to be on Google Classroom. We've been asked to have a working Schoology, so that's why all of the sudden I had a Schoology, but you really don't need to worry about that per se. You can just go through Google Classroom or that e-learning Google Doc that I shared with you through Google Classroom. I'll try to post links to like these videos and any worksheet you might have. If it's just WebAssign, then I'll note that it's WebAssign and it'll be on there. If you get confused, if you don't know what you're supposed to be doing, just ask questions. I would be happy to clarify. I'm not going to be upset with anyone for not knowing exactly what's going on right away. Okay. So here's what you are supposed to do today. All right, so today you are supposed to watch this video, read through Welcome to e-learning. We're going to have a Google Meet today at 11. I will put that code in the Google Classroom, and that'll be just a time for me to help answer questions and things like that. It helps to have already seen this video, so hopefully you've seen this video, and we're not going to have any quizzes or tests for a while, so we'll see how assessment goes in a bit. Okay, on most days I won't have that intro because you'll know what's going on, so the video will be a little bit shorter. Okay, well, we were right in the middle of solving logarithmic and exponential equations, so we're going to pick up exactly where we were. Okay. If you see me looking off to the side, it's because that's where my other screen is. Hope that's not disconcerting. Okay. If you have a logarithmic equation, you have, if you have an exponential equation, things are going really well. You have 2 main strategies to solve it. You can either take the log of both sides, or you can switch forms. Now, for something like problem number 6, obviously you would already just know that the answer is 3, because 5 to the third is 125. If you were to take the log of both sides, that would be using the inverse property. It would look like this. We would use a base of 5 because that's the base of our exponential function on the left side. And then that inverse property, remember from way back when, told us that this equals x, like the entire left side. So x equals 3. However, if you want to, you can also just switch forms. So what that would look like is to say, okay, I know that I have a base of 5, and I'm trying to use an unknown exponent to end up at 123. So base of 5 ending up at 123 means your argument would be 123, and your unknown exponent, a log equals an exponent, so the unknown exponent is on the other side over there. Okay. In cases like this, you would just want to leave your answer as log base 5 of 123 because it doesn't simplify at all. If you watch other videos on this online, you will see people not rewriting it, but actually using that inverse property. So for example, whoa, golly, I don't know what happened there. So for example, on problem number 8, you would see someone take a natural log of both sides. The reason you would take the natural log in this case... Sorry, I think you might have just heard my dogs. It's okay, Luna. Chill out. The reason you would take the natural log of both sides here is because we have a base of e. So this would be x equals the natural log of 15. That's our final answer because we don't have anywhere else to go with that. Okay, moving on. So if you have one exponential equation or one exponential function, you want to make sure that exponent is isolated. Then you want to either take the log of both sides, pay attention to the base, or you may be able to write in log form, you may be able to switch from one form to the other. Okay, so if I gave you a more complicated one, I'm wondering if you could solve this equation. Okay, so pause the video, give it a try, see if you can solve this equation. Okay, so here's my work. I got x equals 1. The inverse property, which you can see right here, would say that log base 3 of 3 to the stuff equals stuff. So that's why that x minus 1 is what pops out of there. Okay? All right, moving on. Using the inverse property for a single logarithm. So if you needed to do this, you've got two options. One is to do a rewrite, which would be to say 2 to the 5th equals x. That's easy. That means x equals 32. You could also, so that's option 1, you could also exponentiate, which means raising both sides to a power. I know this looks the same and it feels kind of like, okay, why am I trying this two different ways? It's just nice to have options. Okay, so 2 to the log base 2 of x is just x, and we get the same answer. Whichever option you take, either option 1 or option 2, you need to have a single log. So in this case, we would have to condense, and we would have to say log base 2 of x squared plus 7x equals 3. Remember, as you do that, sorry, I got a dog doing something inside of the room. Remember that as you do that, adding two logs together is the same as multiplying together inside one log. Okay, so let's take the first option here, just switching forms. We have a base of 2 and an exponent of 3, and we want the result to be our argument, so x squared plus 7x. So we get this quadratic, we get 8 equals x squared plus 7x, or 0 equals x squared plus 7x minus 8. Okay, so we're going to solve that, and then as we solve that, we're going to check to see if there are any extraneous solutions. Okay, so as we solve this, we get solutions to the quadratic that are x equals 8 and x equals 1. Sorry, x equals negative 8. Silly me. Okay, now as you go to plug that in, so say for example here, we get log base 2 of negative 8. We don't use negative arguments in our logarithms, so that is an extraneous solution. And our only solution here is 1. All right, so isolate the log. You may need to condense if there's more than one log. Use the inverse property, which is exponentiating both sides, or switch to the other form there. Okay, make sure you check for extraneous solutions. You do not want either the log of a negative or the log of 0. Okay, so here are some problems for you to try. So pause the video, give those a try. I will reveal the answers, and then you can ask me about these questions in the Google Meet today at 11 if you have questions. Okay, so pause the video because I'm going to reveal the answers in just a second. Did you pause the video? Pause the video. Okay, so there are the answers. If you have questions about any of those problems, let me know. Now, one thing is, I need you to give your answers in exact logarithmic form. Okay, so, for example, your answer to problem number 1 should have been the natural log of 19. So between now and the Google Meet, make sure that you have these answers as logs in exact form. And we can talk through how to do that if you're not exactly sure how to do it. Okay? One last thing to try, and I swear that this problem was in this lesson before now. This is not something that I just made up because of our current situation. Go through if you want to and try this as a stretch problem. See if you can figure out how it works. See if you can figure out an exact answer and a contextually rounded answer and that sort of thing. Okay? See you at the Google Meet, and bye.